Hi everyone, welcome to MindMajix, which is your skill partner. Today we are going to show a demo for microservices and its trainings. Okay, let me introduce myself. I'm working as a Java developer, and my whole career I haven't worked for Java and some basics Python. I know latest of Spring and microservices. I have been working with the last 2 to 3 years. Okay. So today in this demo, we'll be showing what is microservices and what is the architecture and what are the design patterns. And I'll be showing some small example of microservices codes, how it is get configured and how they talk to each other. So basically, this video is on the small demo regarding microservices and this architecture. What is microservices? What is the architecture of microservices? And I'll be showing you what are the examples of small microservices and how to configure it. Okay, and in whole course we have some course outline. We'll be showing you the evolutions of microservices and the architectures, how to design, because there are many design patterns how to design, and design patterns should be must, and we should learn it must, because for every big projects when you work with multiple people and multiple developers, we need to follow certain design patterns. So we need to learn how we can see how we can learn these design patterns. And we'll be using Spring Boot, the framework for Spring. We'll using Spring Boot with the microservices, and we'll be using RESTful web services because SOAP is nowadays is outdated kind of thing. Everybody is using RESTful web services, so we'll be going through RESTful web services with Spring Boot and microservices. Then afterward, I'll be showing you how to do authentication and security in microservices, tastings, and how you do the logs and analysis in the microservices. Okay, then this docker is a container where we store our services, and these are some advanced word we'll be learning about that. Jenkins is a CI/CD tool. Like, we create our microservices and we need to store it in a cloud or in somewhere else, so that the API, or which is calling, let's say, Jenkins is a deployment tool. You could say like through Jenkins, we'll deploy our microservices, or any services which we wrote in our local, will deploy in the AWS or whatever the cloud infrastructure we use. So this is CI/CD. CI/CD means continuous integration and continuous deployment, which we use in Jenkins. Start coding and you start developing the application, and you just save it and it will deploy into the production, so you don't need to deploy manually. These are some different advanced topic. We'll be going through that, and in the end we'll practice and test the interview question for microservices. So these are the course outline for microservices, and I have added some add-on topics. I'll be letting you know what is the web service, what is the RESTful web service, and REST API with example of code and Spring Boot. In Spring Boot we'll be learning all the small annotations and how it helps with them, how it helps the microservice to be connected. Everything we'll be learning in our sessions. And in this slide I have provided some links which can help you out for your references. So you can follow this microservice IO, and for registering all service. So registering all services means the microservices will which will develop will need to store it in a registry or a server, right? So that server, for that I have given some reference to you. We can look into that. And I'll be making a small project regarding a microservice, like a shopping cart, where we have payments, where we have orders. Payment service and order service, see, these are microservice are different. Okay, payment is a service, order is a separate service. So these two services will talk to each other, and they will give us a cumulative of response which microservice stands for. Okay, I'll be showing you all the projects and architecture. and these are the lab setup. Means you need to have some internet, good internet speed, at least 500 GB of STD and 16 GB of memory, or at least 8 GB of memory will be perfect for you. And I'll be helping with you with some certification like LinkedIn certification and IBM certification, because I have done all this certification on my own. So I'll try to make you get the certification also. So what it says, after completion of the course, we conduct a mock interviews to all the participants who wants to evaluate themselves for applying this job. Okay. So all our courses will be over, and everything, course and lab will over. We'll be setting up your mock interview. Mock interviews will be taken by us to show how actual interview is will be there. Okay. So this is the final certificate which gonna be provided to you after you complete your whole course and successfully. Okay. So these are the introduction, small introduction I have show it to you as soon as possible. Let's move it to the actual thing, which is actual content. Okay. So I'm just gonna to show you like what is microservices and what is the topics which gonna be I will cover, and what is the principle, what is the design pattern. Okay. So at the beginning, we need to see what is microservices, right? So microservices, the word itself says its meaning. Micro means small, services means small projects. So here you can see, I assume you guys have already some experience in creating small project with the Springboard or anything else. Okay. So if you are coming to microservice means you have already completed those. So I'm assuming you know those. So creating small services. So let's say this account is a service, inventory is a service, and shipping is a service. We have three services, right? When this account service is a monolithic application, inventory service is a monolithic application, shipping service is a monolithic application. Okay. So when we, let's say when we combine these three application into one application, that is a monolithic application. We are now talking about microservices. So one application we have break down to three services. One is account, one is inventory, one is shipping. So now three services are working and communicating with each other. Okay. As you can see in the diagram, three services are working and communicating with each other to show the, to take the request and send the response. So these are called microservices. If we go to the statement, it says that microservices is an architecture. So normally people thinks that microservices is kind of a, it's not a syntax, or it's not a framework. People think that it's a framework. Okay, this is a misconception around many people or many students are there. So microservice is nothing. Microservice is an architecture. So how you make your own services, you will be making your own services using Springboard and is same syntaxes. Only you need to combine, only you need to talking to each other. That is microservices. It is an architecture. So what it says, microservices is an architecture or architectural style as an application of a collection of small autonomous services. Here you can see this is a small autonomous services, this is a small autonomous services, and this is a small autonomous services. So these are the small autonomous services combining each other will called microservices. Okay. So microservices has some certain principles and some design patterns, as I told you, because microservices are because the whole one application, when we break whole one application to different small services. Okay. So we need some principle, right? We need some patterns, so that let's say we have multiple developers, like we have 100 of developers. Some developers are working in account service, some developers are working in this service, some developers are working in this service. So what will happen is, when will not be followed a single pattern. Let's say I'll give you an example. If you go to your road, right, you ride your bike or you ride your car, thousands of people cross one traffic post at a time. So there is a pattern, right? When red light you stop, when green light you start. So there is a pattern where all the people obeys the pattern, and the traffic goes smoothly, right, without any accident. Like that, if we follow one pattern, all the teams or all the services, your application or our application not gonna be crash, or not gonna be show multiple bugs, kind of like that. Okay, so we need to set an design pattern, and we have some certain principles so that we need to follow. Okay, so we know that, just we covered what is microservices. So as you know, the multiple services accumulatively call as microservices. Nothing much is there, so that we don't think like there is some certain syntaxes or some frameworks are like that. These are some independent services will be calling to each other, will call will call as a microservices. Okay, so here we can see the principles, right? So for, as I told you, to work in a microservice environment, we need to follow certain principles. Okay, so I'll be taking you around all the principles. What is independent and autonomous services? So every services are independent and autonomous, means they will work on their own. Scalability means, let's say, I'll give you an example. We have account service. Let's say, let's think these all three services are inside a Flipkart service. When you go to Flipkart, you, let's say, inventory service, you assume that in Flipkart you see all your mobiles, laptops, dress, these are coming from inventory service. After you select one product, you go to payment service, which is account service. Let's assume like that. Okay, you go to account service. From account service, when account, like, everything is set up, you paid for the that particular product, then your request come to shipping service. Okay, and your product gonna ship, you can track all these shipping services. So scalability means these three services are not dependent to each other. If I need to scale something, let's say I need to upgrade something in my inventory service. Let's say I am carrying 100 of products now. I need to carry 2000 products. So I'll scale this service only, which won't affect account service and shipping service. So that is called scalability in microservice. Okay, decentralization. There is no centralized service there is no dependency of a central service. Centralized service comes for the monolithic application. I'm repeating, these are all the principles and design pattern we need to follow. And there's the must in the microservices. So resilient services means, I'll show you what is the I'm talking about. Resilient services means, you come to Flipkart. Let's assume this is a Flipkart, and inventory, you see all the products in the inventory. Account, you go to payment, and shipping for all your addresses, kind of thing. Let's say there is a bug comes for the shipping service. So your shipping service going down in Flipkart, the shipping service going to down. Okay, but other people who are coming for see the product, or the people who are coming to, like, they saved in the cart and they want to payment, they can do it now. Those, if those services are working independently, they can see the products, they can do the payments, they can do everything except shipping. When shipping service will fixed, they can do the shipping also. Main motto of this resilient service is, if some service is going down, whole application won't going down. Let's say the bug come in the shipping service, your Flipkart application, your whole Flipkart application is not gonna down, or it's not gonna crash. You can go to see the products, you can go to do the payments. If it's a monolithic application, let's say it's threes are combined in a one application, then if it come there is a bug in shipping service, shipping item, then whole Flipkart you can't see, right? You can't scroll anything, because it all gonna die, like nothing, everything gonna crash, right? So this is the benefits of microservices. If some service going down, other service not gonna be hamper itself. Okay, We'll be talking about everything in the code and in the further session. These are the short sessions, so I'm doing the speed up. So these are real-time load balancing. Real-time load balancing means in the server we have the CPU and GPU. Okay, as per the request we can adjust our CPU and GPU, and we can do the load balancing as per the request. Okay, and it's showing the availability, continuous delivery through DevOps integration. DevOps will be, I'll be showing you how to do integration and everything, all for all the microservices. Okay, so these are the main principle we need to follow to work under microservices. Next, we have design patterns of microservices. Okay, so we have many design patterns in our microservices, many design patterns. So let's talk about first design pattern, that is aggregator design pattern. Aggregator means in a computer world you can see like aggregator means we collect all the requests. Let's say there is a web page here. Okay, there is a web page here, and the request comes to the web page. That web page takes the aggregate request and sends to the services. It's the service B, service A, and these are the database structure. So aggregator pattern means all the requests will be collected and sent to the each services. This is a aggregator pattern, and I have given all the theories part here. You can go through also. And next is API gateway design pattern. See, we here in aggregator pattern we have some issues like if there is a certain different request, like we have different protocols, right? HTTP protocol, HTTPS protocol, there are many type of different type of request will come. So in aggregate pattern it will send all the requests to the services, or it gonna be crash, or it will show you some bad response or bad request. Okay, to avoid that we have next pattern, that is API gateway design pattern. API gateway design pattern says that the request which is coming from the client or the web page, it will go through the API gateway. Okay, API gateway will evaluate which request gonna send to which service, and the API gateway has some various functionality also. It can evaluate, it can authenticate the request itself. Let's say this client is not for our service, this client comes from different service. So API gateway can authenticate that this person is authorized to fetch our service details or not. So there are many functionality for API gateway. Will be looking forward that. Okay, so API gateway will evaluate which service to be, which the request, there is, let's say there is two requests is coming. Okay, the API gateway will evaluate which request to be sent to which service. And you can see there is a load balancer also, which will balance the load as per the request. As I told you before in the principle, it will, the CPU and GPU will be, you can increase the CPU and we can decrease the GPU as per the request. So all the load of the server will be balanced. Every request will be connected to our service, and everything, the flow will be in smooth way. Okay, so these are the API gateway. We have several gateway. Mostly we use Joule gateway for this gateway purpose, which will handles all the request and send back to the services, and that does the authentications also, and that does the load balancer. Many things they do. So API gateway is the best way to handle all the request. And again, these are some theory part. Will be, you can go through this theory part also. Yeah. The next pattern is chained pattern. Okay. Chain pattern means there are, let's say, assume there are three services are there: service A, service B, and service C. The request which comes to service A is dependent on service B, and service B request dependent on service C. We, these all scenario will be going through the full course, but I'm showing you the design pattern. What is the design pattern? So service A will be going to service B, and service B request will going to service C. After going to service C, the request fetched from the database all the details, and the service C will return to the service B, and service B will return to the service A. So these are a chained manner. You can see the arrows. These are the some chained manner. See, the requests are coming and the response are going service to service, service to service. Okay, so these are chained pattern. But there is a exceptional thing here. There is a con here. So the cons part is, if my request, let's say this is a client and it wants a data from service C, okay, he doesn't want data from service A or service B. He wants data from service C. He can't do it in the chain pattern, right? Because he can do it, but response latency will be increased. Means the response time will be increased. He need to wait and wait and wait. After like a long time, the response will come, right? Because it has to go to two different services and it will return after two different services. To avoid this, we have a next design pattern, that is asynchronous messaging design pattern. Okay, this design pattern is made because of the client can request to the direct. You can see, I told you before, service A, service B, and service C. Here in the diagram, you can see the request is coming directly to the service C and service B. It's not coming from A to B, B to C, and again C to B, C to A. It is coming direct to the service C. It is taking the response, and we have the queue concept here. Okay, queue means, all the queue data structure, everything will be stored in a queue. Okay, and after that, every response is collected and sent back to the client. So see, if the client doesn't need to wait so much time to get the response, because it's not coming as a chained manner. The response directly come to C and collected all the response and get back to the client. These are the asynchronous messaging design pattern. Okay, we have database design pattern. Basically, it is a best practice to have separate database per services. What I mean to say, let's say I have service A and service B. If we do, if we share the same database, let's say here you can see in the example we have service C and service D. These two services are sharing one database. Although we can use connection pooling and other things we have, right, to avoid this services, so avoid this database pooling. So we have service D and service D, where we are sharing only one database, right? In one database, when we share two different services, there are many more chances where the data will be corrupted or the data can be shared. So it's based or recommended that we'll be using different databases as per the services. Okay, so there are many more patterns like this decomposition pattern, circuit breaker pattern. So I'll share this payment PPT and I'll share all the URLs so that you can go through this. Okay, I'll show you what are the microservices in live project. Okay, how we configure these projects. Let's say this is a project called SIC project. Okay, and this is our Joule gateway. I told you before that we have a gateway approach, right? Where is that? Let me show you once. This is an API gateway approach. What API gateway does? The client request, it collects the client request, it verifies, it authenticates. After that, it sends the request to the particular services. Okay, so here you can see we have a Joule itself. For the gateway request we use Joule. Okay, this is Joule gateway. What Joule gateway does, let's say I am sending a request. Okay, the request will come and check in our application properties. Okay, let's say I have a project called SIC, this one. Okay, this is the project. Okay, so it will map here because my SIC project, it has the port number is 8081. Okay, I have started that project, it is running into the 8081. Okay, the request will come to Joule first. It will check the in the URL we will be passing SIC to secure package. Let's say the URL will be like that. I'll give you an example. Let's say Joule gateway. Okay, Joule gateway is running on a port that, that is. Give you an example. So Joule gateway, it is running on a port that is 8000. Okay, so my request will be, let's say https colon double slash localhost colon 8000. So 8000 means it is calling to my Joule gateway. Okay, so Joule gateway, first the request will come to the Joule gateway. Okay, after that I need to route this request to this SIC application. Okay, that SIC application is running on the port number 8081. I don't need to directly call this URL. I'm telling you again, I don't need to call this URL again. What we need to do is we need to expose only the name here, which is associated with the these properties. So I'll show you how we'll do it. We'll take this, we'll do like SIC, this one. Okay, if we go to SIC application, there are several endpoints. Okay, let's say the endpoint is called get payments, payment data. Okay, if we send this request, what will happen is the request itself, it come to Joule gateway, which I told you, the gateway. The gateway will map the second of here, this one you can see the service name. It will map the service name within the package, and it will redirect to the this one, that particular package itself, which is running into the 8081. When the request will go to the this particular package, in the controller we have several endpoints. Let's say one endpoint is called get payment data, and it will hit the get payment data and it will show you all the payment details. Okay, so this is the short intro how we can configure and how it runs in the microservices. There are many microservices, you can see 30 to 40 microservices. We'll be learning one by one, each by one microservices. I'll be showing you creating one small microservices, how to configure with the Joule, how to how to register in the Eureka, and how to configure in the Joule. Everything we'll be learning coming forward. So this was a short intro or short demo about microservices. Thank you.